There are several things to talk about when it comes to quantum mechanics. While the phenomena are simple to study on basic level, but students which are new to this subject always have had bad time wrapping their mind around the spooky stuff. So let me present you a short-term memory loss electron experiment. I mean a video on famous Gerlach experiment, which was performed by Stern and then by Gerlach in early quantum era, which means that the time quantum mechanics wasn't that famous. Whereas experiment itself is one of the basic blocks of quantum science. Yes, science. There are plenty of quantum stuff going in the different streams. Let's see what this experiment is all about. But first, why don't you just click that like button and subscribe the channel for more physics related stuff. So Stern performed an experiment using silver atom. And when we see at the configuration of silver atom, we may found that they have only one electron in their valence shell, which means that spin was already determined by that valence electron. So a superheated beam made by these collimators and a specially designed magnets to give them direction, which means they have to have interact with each other in order to attain the desired position. Okay, let me explain you. The thing is, there will be an interaction between the field of the electron and the inhomogeneous magnetic field. So there we have to think what would be the actual result. So one may think that the result will be a straight line on the screen. In fact, even though all the things are random, but the final result obtained was not that random at all. What they found is a beam got break into two halves. Exactly. This is the original slab showing the actual results of the experiment done by Stern and Gerlach. This experiment backed the concept of space quantization. So what is it? Space quantization, which means the particle does not possess the same nature as the classical world, elaborating it as if classical world particle can take any orientation as it wants. But in quantum world, the orientations are always quantized in nature or predetermined by the surrounding. But this is not the actual thing we're gonna discuss. This is just a setup. We are actually interested in a sequence of these experiments. So what we are doing is stacking SG experiment one by one ahead of each other to see what the last result will be. Let's assume SG experiment which has a direction to Z, and the beam that goes into it will break into two components, Z positive and Z negative. So out of these Z plus and Z negative direction, when we block a direction, let's say Z negative, and pass the Z positive in another SG Z direction operators, we may found that these Z plus negative only gets one out of the two. Yes, the result will be only one beam out of two. Certainly someone will say that that's not a shocking result, cause we already block Z negative direction and what we get now is only Z positive. That will be the simplest explanation. But let's change our operators a little bit. Now second time when we're placing the SG operators, let's change its direction to say X. Now that Z component from the first operators will again break to 2, means it will break to X positive and X negative. Let's assume the particle was in classical world and we may polarize it to a certain direction. We should not get any of other directions instead of what we polarized it. But in quantum levels, if we polarize a light through SG operators to a certain direction, it may also have all other components in it while we make them pass through another SG, but in that case it should be the direction which was orthogonal to the original one. And someone said that if quantum mechanics doesn't profoundly shock you, it means you haven't understood it yet. Well, to be honest, I was also shocked when I read this phenomena from my Griffiths textbook. In the explanation, scientists theorize that the electrons remove its memory once it travels through an SG operators. What are your thoughts about this experiment? Write them down in the comment section, and I'll meet you somewhere else with another interesting topic. Thank you so much for watching this video. Also do subscribe to channel if you want more of these stuffs. My name is Radip Singh. You're watching channel Tranquil Mortal. I'm signing off. Bye bye.